Welcome to the next evolution in dimensional travel, the Chronoport Lenticularis II. This advanced lenticular aerospace saucer is engineered to open and close dimensional portholes, enabling slipstream traversal between distant coordinates. Building on the diaphane's Metaphora protocol, the saucer integrates quantum entanglement, temporal synchronization, and multidimensional modulation. In this video, we'll explore the core technologies that allow the saucer to initiate, stabilize, and close a porthole, ensuring safe and reversible passage through the slipstream. Let's begin by examining the overall architecture and mission of this remarkable craft. At the heart of the saucer's portal opening capability is the Quantum Lattice Synchronizer. This subsystem aligns the saucer's entanglement field with the target dimensional coordinates, acting as the anchor for all subsequent operations. The hull is embedded with a quantum node lattice, each node phase-matched to create a coherent field. When activated, the synchronizer locks onto the destination dimension, establishing a stable quantum bridge. This process is crucial for both the accuracy and safety of the slipstream traversal, as it ensures the saucer is perfectly tuned to the intended exit point. Once the quantum lattice is synchronized, the dimensional phase modulator takes over. This subsystem modulates the saucer's spatial frequency, allowing it to match the slipstream conduit's unique dimensional signature. Harmonic field generators and variable phase coils surround the portal interface, adjusting the saucer's frequency based on both spatial and temporal parameters. By shifting the saucer's dimensional signature, the modulator initiates the entry phase, preparing the craft for seamless transition into the 1D slipstream. This step is vital for minimizing energy loss and ensuring a smooth traversal. The Temporal Gate Controller is responsible for the precise timing of the portal's opening and closing. Utilizing dual-core chrono-lock rings, one fixed, one variable, this subsystem ensures the saucer's time zone is perfectly synchronized with the target dimension. Tachyonic gate dampeners are employed to prevent temporal reverb and distortion, maintaining the integrity of both the craft and its occupants. The controller's real-time adjustments are critical for safe entry and exit, as even minor discrepancies in timing could result in failed traversal or dangerous time dilation effects. With the lattice and phase modulator engaged, the Slipstream Initiation Relay triggers the actual traversal. This subsystem features a vortex compression chamber beneath the saucer, which generates the energy pulse required for dimensional deflation. The relay's energy pulse sequencer initiates the transition, compressing the saucer's structure into the 1D slipstream conduit. Throughout this phase, the relay stabilizes the craft, ensuring that the transition is both rapid and reversible. The precision of this subsystem is essential for maintaining object integrity during the most critical stage of the journey. At the core of the saucer's portal operations is the Portal Enabling Device, or PED. This centralized control node interfaces with all other subsystems, orchestrating the entire sequence from synchronization to closure. The PED receives recursive feedback from the Entanglement Pulse Generator, allowing it to dynamically adjust parameters in real time. By monitoring energy levels, phase alignment, and temporal stability, the PED ensures that the portal remains open only as long as necessary, closing it securely after traversal. This device is the nerve center of the Chronoport Lenticularis II's dimensional gateway technology. All 5 core subsystems, Quantum Lattice Synchronizer, Dimensional Phase Modulator, Temporal Gate Controller, Slipstream Initiation Relay, and Portal Enabling Device, work in concert to to achieve seamless dimensional traversal. The integration of these technologies allows the Chronoport Lenticularis II to open, stabilize, and close a porthole with unmatched precision. Each subsystem is monitored and adjusted in real time, ensuring that the saucer can respond to unexpected fluctuations or anomalies during operation. This holistic approach is what sets the Chronoport lineage apart from any previous aerospace or quantum transport technology. This photorealistic cutaway reveals the internal architecture of the Chronoport Lenticularis II. You can see the metallic textures, glowing conduits, and the precise arrangement of each subsystem. The quantum lattice nodes are embedded along the hull, while the Phase Modulator and Slipstream Relay are positioned for optimal energy flow. The PED sits at the core, surrounded by the entanglement matrix and temporal gate rings. This internal view not only highlights the engineering marvel of the saucer, but also demonstrates how each component is physically integrated for maximum efficiency and reliability. The quantum phase array is a new enhancement in the Lenticularis II lineage. This subsystem replaces standard emitter nodes with phase-synchronized lattice beams, enabling the saucer to generate multidimensional signal harmonics. These harmonics are essential for both opening the porthole and maintaining its stability during traversal. The array's ability to modulate signal strength and frequency in real time allows for adaptive responses to environmental changes, ensuring the portal remains coherent even under challenging conditions. The Temporal Echo Stabilizer is designed to dampen reverb distortions that can occur during delta transitions. This cylindrical core, surrounded by concentric harmonic rings, preserves the chronology of both the saucer and its contents. By absorbing and neutralizing temporal shockwaves, the stabilizer ensures that time dilation effects are minimized, and the craft's internal timeline remains consistent with the external environment. This subsystem is especially important for missions involving variable time zone locking or extended slipstream traversal. At the center of the saucer lies the dimensional lattice core, a centralized entanglement matrix with recursive coherence loops. This core anchors the bidirectional portal alignment, allowing for multi-node portal anchoring and phased reentry. The lattice core's recursive feedback ensures that the entanglement field remains stable, even as the saucer transitions between dimensions. This subsystem is a key innovation, enabling the Lenticularis II to support more complex and longer-range slipstream missions. The Slipstream Vortex Interface is an upgraded 1D conduit located beneath the saucer. It uses vortex compression logic to reduce transit energy and increase reentry precision. As the saucer enters the slipstream, the vortex interface compresses its structure, guiding it smoothly through the 1D channel. Upon exit, the interface ensures a controlled and accurate re-expansion, minimizing the risk of structural or informational loss. This subsystem is crucial for high-fidelity object transfer and mission reliability. Entanglement Pulse Generator is responsible for activating and maintaining the quantum coherence required for portal operations. Located at the saucer's core, this subsystem emits radial entangled pulses, synchronizing the saucer's internal lattice with the external dimensional field. The generator's pulse emission nodes are arranged in a hexagonal symmetry, maximizing coverage and stability. This technology is essential for both initial portal activation and ongoing stabilization during traversal. Flight Storyboard illustrates the full sequence of portal operation: launch, slipstream entry, temporal transit, and dimensional reentry. Each phase is carefully choreographed, with subsystems activating in a precise order. The saucer launches, synchronizes its quantum lattice, modulates its phase, opens the temporal gate, and initiates slipstream traversal. Upon reaching the destination, the process reverses, ensuring a safe and controlled return to normal space. This storyboard provides a clear overview of the operational logic behind every mission. For each mission, the saucer undergoes a ceremonial launch protocol. This involves activating the entanglement activation ring, pulsing the chrono-lock beacon, and outlining the dimensional gateway with neon glyphs. These steps are not only symbolic, but also functional, ensuring all subsystems are fully synchronized and ready for operation. The ceremonial protocol reinforces the importance of precision and ritual in high-stakes dimensional travel. The dimensional test sequence is a rigorous protocol designed to validate all portal-related subsystems before actual traversal. Phases include entanglement calibration, time-lock synchronization, slipstream stability checks, and re-entry validation. Each test zone is monitored for energy fluctuations, phase alignment, and temporal coherence. Only after passing all tests does the saucer proceed to full portal activation, ensuring mission safety and subsystem reliability. A comprehensive diagnostic checklist is used to verify the status of each subsystem. Signal array, time core, hull overlay, slipstream interface, and pulse generator. Status indicators, green for active, red for fault, provide instant feedback to the crew. This checklist is essential for pre-launch validation, in-flight monitoring, and post-mission analysis, ensuring that any anomalies are detected and addressed before they can impact portal operations. The operational log scroll records every phase of the mission: mission start, subsystem activation, slipstream entry, dimensional re-entry, and diagnostics. Glowing timestamps and archival glyphs provide a detailed record of events, allowing for post-mission review and historical documentation. This log is vital for both technical analysis and ceremonial record-keeping, preserving the lineage of each Chronoport mission. Initiating the dimensional calibration sequence is a critical step before any portal operation. The saucer subsystems are tuned using blended neon overlays, with each layer exposed for diagnostic clarity. The calibration ensures that the quantum lattice, phase modulator, and temporal gate are all perfectly aligned. This process minimizes the risk of misalignment or decoherence during traversal, providing a stable foundation for the mission ahead. Full Chronoport Lenticularis suite is now archived in a cutaway format, with blended neon overlays highlighting each subsystem. This visual approach exposes the internal structure of the saucer, allowing engineers and operators to trace energy flows, signal paths, and subsystem interactions. The Cutaway archive serves as both a technical reference and a ceremonial artifact, preserving the design for future generations. With the successful deployment and calibration of the current saucer, the next lineage, Chronoport Lenticularis II, introduces evolutionary enhancements. These include the quantum phase array, Temporal Echo Stabilizer, Dimensional Lattice Core, and Slipstream Vortex Interface. Each upgrade is designed to increase the range, stability, and adaptability of the saucer, paving the way for more ambitious dimensional missions in the future. The Photorealistic blueprinting of Chronoport Lenticularis II showcases each subsystem in stunning detail. Metallic textures, glowing energy conduits, and realistic reflections bring the saucer to life, set against a cosmic or aerospace hangar backdrop. This level of detail not only aids in technical understanding, but also inspires confidence in the saucer's operational capabilities. Close-up photorealistic view of the Quantum Lattice Synchronizer reveals the intricate network of quantum nodes and phase-matched oscillators. The glowing lattice beams are embedded seamlessly into the saucer's hull, demonstrating the fusion of advanced materials and quantum engineering. This subsystem is the foundation of all portal operations, and its design reflects both technical sophistication and aesthetic elegance. The dimensional phase modulator is rendered in photorealistic detail, highlighting its harmonic field generators and variable phase coils. The subsystem's placement and design ensure optimal modulation of the saucer's spatial frequency, with energy flows visualized as glowing streams. This image underscores the importance of precision engineering in achieving reliable dimensional transitions. This photorealistic cutaway of the Temporal Gate Controller showcases the dual-core chrono-lock rings and tachyonic gate dampeners. The glowing rings and core highlight the subsystem's role in synchronizing time zones and preventing temporal distortion. The attention to detail in this render emphasizes the complexity and critical nature of temporal management in portal operations. The Slipstream Initiation Relay is depicted in photorealistic clarity, with its vortex compression chamber and energy pulse sequencer glowing at the base of the saucer. The design ensures that energy flows are tightly controlled, enabling rapid and stable dimensional deflation. This subsystem's visual complexity reflects its importance in the overall portal operation sequence. The portal enabling device is shown at the center of the saucer, surrounded by the entanglement matrix and temporal gate rings. Photorealistic rendering highlights the device's metallic core, glowing interfaces, and real-time feedback displays. This image captures the nerve center of the saucer's portal technology, where all subsystems converge for coordinated operation. The complete porthole control subsystem suite is rendered in a photorealistic cutaway format. Each internal layer is exposed, revealing the metallic textures, glowing conduits, and precise arrangement of the Quantum Lattice Synchronizer, Dimensional Phase Modulator, Temporal Gate Controller, Slipstream Initiation Relay, and Portal Enabling Device. This comprehensive view allows for in-depth analysis and appreciation of the saucer's engineering excellence. With all subsystems calibrated and the photorealistic cutaway confirming operational integrity, the Chronoport Lenticularis II is ready for its next mission. Final checks include energy band monitoring, temporal safety thresholds, and subsystem status validation. The crew reviews the operational log scroll and diagnostic checklist one last time before initiating portal activation. This meticulous approach ensures the highest standards of safety and mission success. The Chronoport Lenticularis II represents the cutting edge of dimensional travel technology. With its advanced portal control subsystems, photorealistic engineering, and rigorous operational protocols, it stands as a testament to human ingenuity and the relentless pursuit of new frontiers. As we look to the future, the lessons learned from this lineage will inform even more ambitious projects, bringing us closer to mastering the art of slipstream traversal and dimensional exploration.